Hey guys, I wanted to explain more about where those numbers that we used to construct the unit circle came from. So hopefully this sheds a little light on that. So if we look at the unit circle, there were three standard angles. And we'll talk about all of them, but first I'm going to focus on the very middle one, pi over 4. So now, pi over 4 cuts the quadrant in half, and the analogous angle does the same thing to each of the other four quadrants, no matter how badly I draw them. So pi over 4 really means 45 degrees. And so if we look at the right triangle that we make, since all of the angles have to add up to 180 degrees, 90 plus 45 only leaves 45 more degrees here for this angle. So that means we've got an isosceles right triangle. So both legs have the same length. Those two tick marks mean same length when they have the same number of them. So both of these are 45. That means, like I said, each of these legs are the same length. So where does that radical 2 over 2 number come from? Well, if we think about it, this has the same length as this, so I'll label them both length x, and this is length 1 because it's a radius of a unit circle. So when we do the Pythagorean theorem, that should be 1 squared equals x squared plus y squared, but each side is the same length. So we get x squared plus x squared, 1 is 2x squared, 1/2 is x squared, and so we get 1 over radical 2 is x, and that's really, if we rationalize the denominator, rad 2 over 2. So that's this length and this length. So that means both coordinates are going to be rad 2 over 2. And that's what we saw when we built the unit circle in class the other day. The only thing that changes in different quadrants is one or both of these coordinates might be negative, but they'll always be the size rad 2 over 2. Okay, so then moving on, the other special standard angles are actually interrelated. So we just look at the first quadrant. There's the 45 degrees right in the middle, then there's one above it and one below it. Now the one below it was pi over 6, this one was pi over 3, and we get those numbers because here's pi over 2, which is 90 degrees. What we've done is we've split the quadrant into thirds. So what's a third of pi over 2? Pi over 6. So that means this is pi over 6, then this is 2/3 of the way through the quadrant, so 2 pi's over 6, which is pi over 3. So that's where those two angles come from. Before we were dividing it in half and we got pi over 4. Here we're dividing it in thirds, we get pi over 6 and pi over 3. Now, these turn out that this is 60 degrees, this is 30 degrees when you do the conversion. And now these two triangles that get created here are actually the same triangle, just positioned differently. Let me redraw this without the shading. Got the middle one, 60 degrees, 30 degrees. So despite the fact I've not drawn them very well, these are actually the same triangle. The reason is both have a 90-degree angle. This is 30 degrees, this is 60 degrees. So if the sum of all the angles has to be 180, the only thing I can put here to make this true is 30, and vice versa. If we have a right triangle and we know one of the angles is 30, the only other number here that could possibly fit is 60. That makes it true. That makes them add up to 180. So this is actually the same triangle. So solving one is going to solve both of them for us. Okay, now in order to do that, I need to take kind of a step back, zoom out a little bit. Let's imagine an equilateral triangle. So that means all three of these angles are the same size, all three of these sides are the same length. Now the only way to have an equilateral triangle is if all three angles are 60, because again, all three angles have to add up to 180, and if they're all the same length, that means they're all 60. Now I'm going to cut it in half. The reason I'm going to do that is because this creates these two triangles that I have here. Because this angle's still 60, this angle's still 60, but this one got cut in half, so now it's 30 on each side. So let me just look at one of them. We've got 30 degrees here, 60 degrees here, so this is the same triangle. Now, this length is 1. Now this was the same length originally, but it got cut in half, so that means this is 1/2. And that's where the 1/2 number comes from. Now we need to figure out how long that side is, so we're going to Pythagorean theorem our way home again. 1 squared should be 1/2 squared plus question mark squared. So that's 1 equals 1/4 plus question mark squared. I subtract the 1/4, I get 3/4. I take the square root, I get radical 3 over 2. That's how tall this vertical piece is. And so that, now the coordinates we know of this are going to be 1/2 rad 3 over 2, because the shorter leg is 1/2 and this taller one is rad 3 over 2, like we just figured out. And the other one, the 30-degree triangle, that's going to go the other way around. This, now the long side is down, so that's rad 3 over 2, and the height is 1/2. So that's where those numbers come from. They come from, these are actually referred to as special right triangles. An isosceles right triangle, and this is called a 30-60-90 right triangle. So I hope this clears up a little bit, makes it seem less like magic where those numbers that we use to construct the unicircle come from.